Hello, young friends. Today we are going to solve question number 7 asked in ICSE 2010 computer application paper. In this question, we must write a menu-driven program in Java using switch case method where we must check whether an entered number is prime or automorphic number based on the choice entered by the user. So, quickly, with the help of a flowchart, we should try to understand what we will do in this program. Right off the bat, we will display a menu to a user where he would enter his choice to whether he wants to check a number is prime or he wants to check that a number is automorphic. As soon he enters his choice, we would apply switch case method to his choice. If he entered 1 as his choice, then we would ask him to enter the number he wants to check, if it is a prime or no. After that, we would check a number and display him the result that number is prime or not. If he enters 2 as his choice, we will ask him to enter the number he wants to check if it is an automorphic number or not. After he enters the number, we will check the number and display the result. If the user enters any other choice, we will display him a message that he has entered a wrong choice and would terminate a program. With that, we can say that there are 3 important things in this program. The first being, how do you manage the choices users make from the menu? The second one is, how are you going to find out the number is prime or not? And the last being, how will you find that a number is automorphic number? So, step by step, we are going to address each one of these issues before we start coding. What is a switch statement? Whenever there are many options out of which only one must be selected, then people usually instantly use if-else condition. It is very handy, I know, but it just makes everything very overwhelming. This is a small snippet from one of my other videos where I have used if-else condition, and look how much complex this simple code looks. All I was trying to calculate was discount. Whereas switch statements too are a multi-way branch statement, but they are very easy and fun to use. I'm not advocating switch case over if else. Both are powerful and super handy. Most of the times we all use if else unless we are asked to not do so, because it is so hardwired into our system and basically it comes naturally to us. If and else, this or that. So how does this switch case work? Let's say we have a variable ch who holds the choice user made. Now, there are 3 possibilities. Either user enters 1 to find out prime, or user enters 2 to find out an automorphic number, or user enters any other number which was not in the menu. Yeah, that's happened too. So, we would apply switch case over the value of ch and come inside switch case. Create a separate case for prime and automorphic number. And the last case would be default case to handle the situation where user enters the choice which is not mentioned in the menu. In every case, we would add the code which does something. In case 1, we will add code to find out prime number. In case 2, we will add the code to find out automorphic number. And in default case, we will just print a message that you have entered a wrong choice. Now, there's a small twist. At the end of every case, you must add a break statement. What does this break statement do? It tells the compiler that, hey, look, I came here to find prime number and my job is done. Please show me the way to exit the switch case universe. What happens if you don't add break statement? So just for the sake of this discussion, let's assume that user entered 1, came inside the switch statement, tried to find whether the number was prime or not. After that, since there is no break statement, compiler would continue executing the other cases too till he finds the break statement. If you don't mention single break statement, then from the point of your entry in switch statement, compiler would execute each and every case. So whenever you are using switch case, always make sure that you write break statement after each case, even after the default. Everybody in class 10 would be knowing what prime numbers are. Any number that only divides by 1 and itself is a prime number. What interesting is to help the computer figure out this by itself. So for that, we would take two examples. One of a legit prime number and other would be a non-prime number. So first number is 7. To find out whether 7 is a prime or not, we will start investigating from 1, 2, 3, 4, 5, 6 and 7. And we will try to find out which number divides 7 successfully. We all know every number is divisible by 1 and by itself. So our focus would be to find out, is there a number between 2 and 6 which divides 7? To make things a little bit simpler, if we divide 7 by 2, we will get 3.5. And if we ignore the decimal part, we only take 3. If you observe one thing closely, there is no chance that any number greater than 3 but less than 7 would divide 7. And this stands true for every number, whether a number is prime or not. That means all we must check whether 2 and 3 divide 7 to find out whether 7 is prime or not. I understand that some of you will get a bit overwhelmed by this approach, but try to understand that if the number user enters is 7001, to check how many divisions you have to do if you go by the traditional approach of checking the divisibility by each and every number. Our method will reduce the number of divisions by more than a half. Last topic before we jump to coding is automorphic number. So, what is an automorphic number? Any number which is contained in the last digit of its square is qualified enough to be called automorphic number. For example, square of 5 is 25. The last digit of 25 has 5 in it, therefore 5 is an automorphic number. Similarly, square of 25 is 625. 625 contains 25 in its last digits, therefore 25 too is an automorphic number. Whereas square of 4, that is 16, doesn't contain 4 in the last digit, therefore 4 is not an automorphic number. The method to check for automorphic number, we will take a number, calculate the square of it, and with the help of loop, we will start extracting the last digits of each number and compare. If any one of the digit doesn't match, then we can conclude that the number is not an automorphic number. After understanding the plan of attack with the help of a flowchart and then understanding all what we have to do in the detail, I assume now it is the right time to start coding the program. Let's quickly import the IO package in Java. It is required to do any activities related to input and output. After that, let's create a class by the name CMD, which stands for check and display. You can change the name to whatever you feel like. After creating a class, we should quickly create a main function. Main function is the most important part of your program, as this serves as the entry point for the compiler to start compiling your program. Let's set up everything so that we can take input from the user. And for that, system.in will accept any input coming from any input device attached to your computer. System.in reads everything in bytes. Input stream reader converts those bytes into chars, and object br of buffer reader read those chars finally and helps you to store them in whatever variable you want. Let's initialize the variables which we will need in this program. Num will hold the value which user wants to check. Ch will hold the choice which user will enter, 1 for prime, 2 for automorphic. I will be used to iterate over a loop, especially while checking for the prime number. Flag is a variable we have defined to have one value until some condition is true. It is a variable that we will use to control the flow of loop and conditions. With the two print statements, let's quickly lay out the menu of the program in front of the user, and with one input statement, we will ask the user to enter his choice and we will save that choice in the variable ch. ReadLine function will read the input in string format and integer.parseInt will convert it into integer format for our further use. Let's apply switch case on the variable ch and start typing for case 1. Quickly take an input from the user which we will check whether it is prime or not. Initialize the value of the flag to be 0. If the number entered by the user is prime, the value of the flag won't change and would remain 0. Else, the value of the flag would be changed to 1. We will run a loop from I equals to 2, and this loop will run till the value of I is less than or equal to num by 2. As I have told you earlier, that if any number between 2 and number by 2 divides the number is not a prime. So, we will set up an if condition to check that for each value of I, can it divide the number. If it does, then we would change the value of flag to 1. An important point here is that since we have reached inside the if condition, that means the number is not a prime number. So therefore, there is no point to run the for loop any further. And the best thing we can do is to come out. The break statement will do exactly that. It will bring us out of the for loop. Now, we will check whether the value of flag has changed or not. See, there is a chance that the entire loop ran and the value of flag didn't change. Or there may be a case that it changed. The point is, we don't know, so the best way to figure out is to check the value of flag. If the value of flag remains the same, that means number is a prime number, else it isn't. At the end, we will come out of the switch by using break statement. If we don't use break statement, compiler will continue executing the next switch case block 2. With that, let's quickly jump to the case 2 of switch case. Ask the user to enter the value to be checked and store the number in num variable. Set the value of flag to 0. Create a temporary variable by the name temp and initialize it with the square of number. Let's start a while loop with a condition that this while loop will run till the number doesn't become 0. Inside the loop, we will be changing num and also we will check whether the number is automorphic or not. The purpose of using a while loop is that we don't know what number has been entered by the user and how many digits are there in it. Even in future, if you find yourself in uncertainties like this, always trust while loop. As I told you earlier that we would extract each digit from both numbers to compare, and if even one digit doesn't match, then can conclude that number is not an automorphic number. To do that, we will write an if statement whereby the use of mod division, we will extract the digit for comparing. If you don't know mod division, it gives you the remainder in any division. And here we will use it to extract the digit. Because if you do mod division of any number with 10, it will give you the last digit of that number. After doing mod division, we will compare the digit we have obtained, and if they are not equal, then we will go inside the if block. Remember, the condition that we have written will be true when they are not equal. In scenario like this, it is much more advisable to construct the condition of something not happening rather than of something happening. If condition is true, we will update the value of flag to 1, which means that number is not an automorphic and we will break the while loop and come out of it instantly. If the condition is not true and more iterations are required, then we must apply some changes to the variable num and temp. We will apply normal division on them and store the result in them itself. On dividing them by 10, we all know that quotient which we will get would have one less digit. Why you want to remove the last digit? There are two reasons for it. First, that we have already compared the last digits and we don't need to compare them again. To compare the next pair of digits, we should remove the digits that have been compared already. Second reason is that when we started with the while loop, we stated that this loop will run till num doesn't become 0. So if we do not remove the last digit from num after every iteration, then this loop will run till eternity. Not eternity exactly, till it will eat up all your RAM and hangs the computer in the middle of nowhere. With this, we have written our while loop successfully, and all is that left is to confirm whether a number is automorphic or not. And to check that, once again, we will write an if condition to check the current value of flag. If the value of flag hasn't changed, that means it is an automorphic number. If it has changed, then means it is not an automorphic number. And By that, we will end the case 2 by adding break statement and quickly write the default block. This block is being written for the scenario that what if user entered something which was not mentioned in the menu. All we have to do inside the default block is to print that you have entered a wrong choice. With that, our code is complete. I hope you have found this video helpful. If you have, please like and share it with your friends. And to watch more videos like these, please subscribe to my YouTube channel and press the bell icon to never miss an update. Thank you.